In this video, we are going to match graphs again, but this is part 2. I very cleverly have named it. We're going to look at what happens when matching f of x to its derivative picture when I have bumps in my curve. So what do I mean by bumps in my curve? It could be something like a parabola. It could be a cubic function. It could have a lot of wiggles. So we'll just start with the parabola first, and then I'll move from there. Okay, so remember that the derivative, I'm even going to write it. The derivative is the slope at each point on the curve, on f of x. Okay, but what I want to do is I want to look at not the actual value of the derivative, but more talking about positive versus negative. So I'm going to use this pen right here as a tangent line. So if I put that tangent line to the curve over here, is that tangent line have a slope that is negative or positive? It's negative. And as I move it along, you'll notice that it's kind of flattening out a little bit, but it's still negative until I get to the bottom, and then it's 0. So here's what I'm going to write. I'm going to write that the slope is 0 here, and the slope is negative on that side of the curve. Okay, now when I come on this side and I start going, is this tangent line positive or negative? That's right, it's positive. It's always positive. So on this side, it's positive. Okay, now when I make the transition from this picture to this picture, what's happening is that the derivative is its own function. Okay, so I'm saying that these y values are going to be the slopes. So my y value is going to be, so when I go over to my other picture, my y value is going to be negative. My y value is going to be 0, and then my y value is going to be positive. Okay. So when I go over here to draw it, these y's are referring to the derivative. Okay, so notice my picture has a slope of 0 at the origin. So that means I'm going to have a y value of 0 at the origin. Okay, over here on this side, it's negative, so I'm going to have y values that are negative. And on this side, it's positive, so I'm going to have y values that are positive. So let's see if we could do this. I'm saying that I'm going to have a y value of 0. Okay. Then I'm going to, on this side of the graph, if you remember, on this side, y was positive, and on this side, y was negative. Okay, so positive y's would look like that. Negative y's would look like that. That is how we have the original function, and that's what the derivative would look like. All right, I'm going to wait for just a second, and then I'm going to do another one, okay, with some more bumps to it. Okay, so here we come, racing. All right, so I'm going to do this one a little bit differently, and I'm going to stack them one on top of each other. I think that might be an easier way to look at it, is vertically. Okay, so if I had an original function, let's give it some wiggles. Like that. Okay, so again, I'm going to take my pen, but this time it's a green pen, and I'm going to talk about tangent lines and the slope. So over here to the graph, this is positive slope until I get to the top of the hill, and there it's 0. So m is 0, m is positive. Okay, now, if I come down below to this graph, okay, notice I put that line straight down. I'm saying that I'm going to have a y value of 0 at that spot. And on this side, the y values are going to be positive. Okay, so that means that on this side of the graph, it's going to be positive. Now, it doesn't matter how I draw this as long as the y's are positive and that they are up above. So, and connected and smooth. So we'll just make it up and go like that. Okay, now, if I keep moving, my slope is negative, and then it gets to 0 again. All right, so I'm going to draw some dashes. Right here, y is 0. And on this, it's supposed to be negative. So y's are negative down here. Now, again, I have to connect these dots. So I don't care how far down you go. We're making this stuff up, but it's got to come back and connect the dots, okay? If you don't want to scoop it that low, you don't have to scoop it that low. You can keep it a little bit shorter. But the point is that it's got to connect the dots. Okay, last little bit. Over here as I go to this side, M, oops, I lost my tangent line. M is positive. So if M is positive, that means the y values are positive. I don't care how we graph it, if you just kind of graph it like that, if you want to graph it steeper. I don't care at this point, guys. It's just a guesstimate of what the shape should look like. So that is how we roughly, quickly sketch. Here's my original function, and here's the graph of the derivative. All right, good luck.